This will be just a quick review of everything we've learned so far regarding the mole, which is now your new best friend for the rest of the school year. We'll talk about just in general what a mole is, the difference between a mole and other things, and how to convert certain units with a mole. Okay, first things first, the mole is a unit that we use in chemistry to count things, and it's equal to quite a few things. It's equivalent to quite a few things. Because it's equivalent to so many things, we can make conversion factors out of each of the things that it is equivalent to. Okay, for starters, 1 mole is equal to 6.02 times 10 to the 23rd representative particles. Okay, a representative particle can be either an atom, a molecule, or a formula unit, or it might just be called representative particles. It just depends on how it's worded in the question, but either way, all of these basically mean the same thing. So again, 1 mole is equal to 6.02 times 10 to the 23rd representative particles. 1 mole is also equal to the molar mass of a substance, and the units for that is grams per mole. It's grams per mole because grams is the unit for mass. So again, 1 mole is equal to the molar mass of whatever the substance happens to be for that question. The last thing we're going to put the mole equal to is 22.4 liters of a gas at STP. Remember I told you guys STP is standard temperature and pressure. Standard temperature at STP is 0 degrees Celsius. Standard pressure is 1 atm, and the volume at STP is going to be 22.4 liters. This only applies to gases. So if the substance in the question, let's just say, is sodium chloride, for example. Sodium chloride is table salt, like what we put in our food. That is not a gas. Therefore, the 22.4, will have no place in that question or in any of your calculations. So again, these are the things that the mole is equal to, and we can use these to make conversion factors to help us do some of the problems that you guys have been doing. Okay, just some hints for solving these mole conversion problems. Everything must go through moles. It has to go through moles in order for you to convert it. If you are doing a conversion problem and you have not converted anything to moles, you are doing it wrong. Everything needs to convert to moles. That is very, very important. Again, everything must go through moles. If you have not converted anything to moles during your conversion problem, you are doing it wrong, and you need to go back and revisit and, just look at what you did and, see if you can correct the error. Second thing, when in doubt, convert to moles. If you're sitting there and you're doing the problem and you're just like, gosh, I don't know what to do, or gosh, I don't know what the next step is. When in doubt, just convert it to moles. Just convert it to moles. And then from there, you might be able to figure out what your next step should be. Last hint I can give you, please, I am begging you. I'm on my knees right now begging you. Use the method that I taught you with the little T-chart. It will come in handy later with the next couple of chapters. You will thank me later if you start using the T-chart now. Please don't try to do it in your head or try to figure out, okay, well, if I multiply this or divide this, because that method is not going to work for you later on, and then you're going to be trying to play catch up. So it'll be more difficult for you later if you don't use the T-chart now. The next thing I want to introduce you to that will help you do some of your conversions is Mole Island. Think of Mole Island as a country, and the main island in the country is Mole Island, but there are 3 other little islands like Volume Island, Mass Island, and Representative Particle Island that you can go visit in your travels there. Now, to leave Mole Island and go to one of the other islands, you have to stay on the road. You cannot jump off the side of the road and go swim over to the other island because there are shark-infested waters, and you will perish if you jump off the side of the road and attempt to swim. So you have to stay on the road to switch to each island. So for example, let's say you're on Mole Island and you want to go to Volume Island because you want to take a picture of a waterfall or something. So you will leave Mole Island. What is your conversion factor to leave Mole Island? It's going to be 22.4 over 1 mole, and that can take you to Volume Island. If you are leaving Volume Island and you want to go back to Mole Island, you would start with whatever volume you were given, and then the next thing you would write in your T-chart would be 1 mole over 22.4 liters. If you do that, your liters would cancel out, you're left with moles, and you're back on Mole Island. Let's say you wanted to leave Mole Island and go to Representative Particle Island. If you wanted to do that, then you would have to leave Mole Island. Your first conversion factor that you would get to is 6.02 times 10 to the 23rd particles over 1 mole. You do that, your mole would cancel, you're left with your representative particles, and now you are on Particle Island. If you wanted to leave Particle Island, you have to start out with the representative particle that you were given. Your conversion factor, the next thing you write in your T-chart, would be 1 mole over 6.02 times 10 to the 23rd particles. You do that and your particles cancel out, you're left with your mole, you're back on Mole Island. Let's say you're on Mole Island and you would like to go to Mass Island. You leave Mole Island starting off with whatever moles the problem is giving you. Your conversion factor will be the molar mass of whatever the substance happens to be over 1 mole. Your moles will cancel, you're left with your molar mass, you can then go to Mass Island. If you're leaving Mass Island to go back to Mole Island, you start out with the mass that you're given in the problem. The next thing you write in your T-chart will be your conversion factor of 1 mole over the molar mass of whatever the substance happens to be. Your masses will cancel, you're left with moles, you're back on Mole Island. So if this helps you, then feel free to use it. If you understand it better the way I explained it to you last time, then feel free to use that way. Either way is, fine. They're basically the same thing. Okay, next we're going to talk about calculations dealing with molar mass. So with calculations dealing with molar mass, either you will be given the grams already, you'll have to find the molar mass to convert to moles, or you will be given the moles, and then you'll have to find the molar mass to convert to grams. But either way, you'll need the molar mass with anything that's dealing with grams. So if the question gives you something in grams, or if the question is asking you to convert to grams or anything of that nature, you will always have to put the molar mass in there somewhere. Okay, in our first example, aluminum is often used for the structure of lightweight bicycle frames. How many grams of aluminum are in 3 moles of aluminum? So if you guys will notice, the question is asking you how many grams of aluminum. So that's what the question is asking you for. And you were given 3 moles of aluminum. Remember, I told you in class you always start out with what you're given. So on the next slide, we will go ahead and solve this. Okay, so I just told you that in order to solve any problem dealing with grams, you need to find the molar mass. Our molar mass of aluminum is about 27. Remember that 1 mole of any substance is equal to the molar mass, so that's why I have 1 mole equals 27 grams. Okay, your conversion factors are one of 2. You have to pick one. It's either going to be 27 grams of aluminum over 1 mole or 1 mole of aluminum over 27 grams. So now our next step is to do our setup with the T-chart. Notice we are using the T-chart. Please use the T-chart. Okay, so we started out with 3 moles. Remember, whatever you're given is what you start with initially. Whatever units you have here need to be the same units that you have down here. That way they will eventually cancel out. So that being said, we have our 3 moles. If we have moles right there, we need to have moles at the bottom. So that's why we choose this conversion factor, because it's the one that has 1 mole on the bottom. So if we set it up like that, our moles of aluminum will cancel out. We're left with grams, which is what the question is asking us for. So we're in the right spot. So now we just multiply the things at the top. So 3 times 27 and then divided by 1. If we put that in the calculator, work it out, it should come out to about 81 grams of aluminum. Okay, our next example tells us that NutraSweet basically has a chemical formula of C14, H18, N2, and O5. It's used to sweeten foods, soft drinks, etc. Questions asking you how many moles of aspartame, or NutraSweet, are present in 225 grams of aspartame. So the question is asking you how many moles, so that's what we want, and this 225 grams is what we're given. So what we will start with when we get ready to solve this is our 225 grams. So just to get it out of the way, the best thing to do initially, since we already see grams, we automatically know that we need to find the molar mass of this aspartame. Molar mass is about 294 grams per mole. Okay, so now that we found that out, we can continue on with our equation. So we start out with what we're given, which is 225 grams of aspartame. This little pen is horrible. Okay, we have our 225 grams. We're setting up our T-chart. So now we have to decide what needs to go here. Whatever unit you have on the left is the one that needs to be on the bottom right. So since grams is there, then our molar mass will have to go on the bottom, which will be 294 grams. And that is equal to 1 mole, which will go on top. Now, when we do that, our grams will cancel out. We're left with moles. That's what the question is asking us for. So that's how we know we're in the right place. So now we can just do our math. So it's just you multiply the things at the top and divide what is on the bottom. Once we put that in the calculator, it comes out to about 0.77 moles of the aspartame. And that would be our final answer. And again, if you were using the mole island, we started out on mass island. So in order to go back to mole island, this is the conversion factor we had to use. Okay, next thing we're going to talk about are some of the 3-step problems, which I know a lot of you guys are having issues with. So just remember that everything must go through moles. Again, if you are doing a conversion and you have not converted anything to moles, you are doing it wrong. You need to go back and look at what you did and see how you can convert something to moles. So for example, if we want to go from grams to particles, we need to change our grams to moles using our molar mass, and then change our moles to particles by using Avogadro's number, which is the 6.02 times 10 to the 23rd. If we wanted to go back and switch from particles to grams, we would just do the reverse. Okay, just some more tips on these 3-step problems. Since 6.02 to the 10 to the 23rd particles equals 1 mole and 1 mole equals the molar mass of something, you can convert from atoms/molecules to moles and then moles to grams. Again, this is a 2-step process. Again, I say, you cannot go directly from atoms to grams. You must go through moles. I saw a lot of this on your homework and other work that you guys were doing, and I wanted to make sure I stressed that a lot in this video. Okay, in our first example, how many atoms of copper are present in 35.4 grams of copper? So the question is asking for atoms, which is what we're looking for. So that should be our end unit. And it gave us 35.4 grams. So that would be our given, and that's what we start with at the bottom. So again, we start with what we're given, which is our 35.4 grams. Remember, if you have grams on the left, you should have grams on the bottom right. So our molar mass of copper is about 63.5. Grams of copper will cancel. We're left with moles. Now at this point, we need to change our moles to atoms because we're in moles right now. The question's asking us for atoms. That's how we know we need to continue. So again, 1 mole is equal to 6.02 times 10 to the 23rd atoms in this case. So our 1 mole will cancel. We're left with atoms. So at this point, we just multiply 35.4 times 1 times 6.02 times 10 to the 23rd divided by 63.5. Remember, when you're doing this, I would strongly suggest putting everything in parentheses. So like all this stuff should be in parentheses and then divided by the 63.5. If you do that and you do the math correctly in the calculator, it should come out to about 3.4 times 10 to the 23rd atoms of copper. Okay, in our next example, we're being asked what's the mass in grams of 1.20 times 10 to the 24th molecules of glucose, and I gave you the chemical formula for glucose. So the question is asking us what's the mass in grams, which is what we want. And we were given 1.20 times 10 to the 24th molecules. That's what we were given. Now notice the question is asking us something about grams. So that means that we need to find our molar mass of glucose, which if you work it out is about 180. So now that we know that, we can continue on and set up our problem. Again, you always start out with what you were given. So in this case, we start out with our 1.20. This little pen is horrible. Times 10 to the 24th molecules. Guys, another thing I want to stress, molecules and moles are not the same. So if the question tells you that you are starting out with molecules, you need to write molecules. Do not write moles because you will confuse yourself. Molecules and moles are not the same. So now that we've set up our T-chart like this, we have molecules here on the left. So that means that whatever unit we put down here needs to also be molecules. So we know that we need to convert to moles. So 1 mole will be up here, and our 6.02 times 10 to the 23rd molecules will be at the bottom. Once we do that, our molecules will cancel, and now we're left with moles. However, the question is asking us for grams, so that's how we automatically know that we need to continue. So we set up another portion of our T-chart. So now that we know we need to go from moles to grams, 1 mole of anything is equal to the molar mass of whatever that substance happens to be. For this question, it's glucose. So 1 mole is equal to our molar mass of glucose, which was about 180. If we do that, our mole will cancel out. We're left with grams. That's what the question is asking us for. So now we know that we are where we need to be in order to solve this problem. So at this point, we would just multiply the things at the top and divide what's on the bottom. Again, I'm going to strongly suggest that you put this stuff in parentheses and then divide it by and then this in parentheses in your calculator just to ensure that it comes out correctly. Once we get all that into the calculator correctly, you should come out with about 358.8 grams of glucose. Again, it's in grams because that's what the question was asking us for, and that was our last unit. Okay, in our next example, the question is asking us what is the volume of 4.59 moles of carbon dioxide gas at STP. So we see STP, we automatically know this is going to be something with the 22.4 liters. We also know that because the question is asking us for volume. The only conversion you've had so far that has to do with volume is the 22.4 liters. So, question's asking us for volume. We're given 4.59 moles. The question is not asking you anything about grams, nor is it giving you anything in grams. So, do you need to worry about the molar mass for this question? No, you do not. Once we get that in the calculator and work it out, it comes out to about 102.8, and our unit is going to be liters of CO2. Okay, our next example, please notice that this is not the same as the one you just did. You have to make sure that when you're doing these kinds of problems that you are reading what the question is asking you for and what it's telling you, because that can make a difference between a right or a wrong answer on a test or a quiz. So the question is saying, what is the volume of 4.59 grams of CO2 gas at STP? Question is asking you for volume or liters. So it's asking you how many liters. And it's giving you 4.59 grams of CO2. So now we see grams. So anytime we see grams, we automatically know that this problem is going to have something to do with the molar mass of CO2. So we might as well figure out what the molar mass of CO2 is right now. Okay, so our molar mass of CO2 is about 44 grams per mole. So now that we've gotten that out of the way, we can go ahead and start setting up our T-chart to solve this problem. You always start out with what you're given. So in this case, it was the 4.59 grams of CO2. Set up our T-chart. Remember that whatever units you have here needs to be the same units that you have here. Use your mole island. Remember what I taught you. So if you have grams here, whatever you have here needs to be grams, and you always want to convert to moles. So if this has to be grams at the bottom, 1 mole by default is going to go on top. 1 mole of CO2 goes on top. So the only grams that you have so far to work with is the molar mass. So we're going to put our molar mass of CO2 down here, which is 44 grams of CO2. Once we do that, our grams of CO2 will cancel. We're left with moles. The question, however, is asking us for volume. So that's how we know we need to keep going. So now, what conversion factors can you make for changing moles to volume? Anytime you see volume, you know it's going to be something with the 22.4 liters. Remember that whatever unit you have here needs to be the one that you have here, so that they will cancel. So if you have moles already, then what you put down here by default has to be 1 mole. It's going to be 1 mole of CO2. 1 mole of any gas equals 22.4 liters of that gas at STP, and this is at STP. So now that we have that written, our moles of CO2 will cancel. We're left with liters, which is what the question is asking us for. So now we know we can stop and we can go ahead and begin to solve this problem. So at this point, we will just multiply the 4.59 times 1 times 22.4 divided by 44 times 1. Once we get all that in the calculator and do our calculations, should come out to about 2.34 liters of CO2. Again, please make sure when you're doing this stuff, you read the question, see what it's asking you, make your conversion factors. Okay, and in our last example, we're being asked how many molecules is 5.67 liters of O2 at STP. Question is asking you for molecules, which is a representative particle. So this question is going to have something to do with the 6.02 times 10 to the 23rd. That's what it's asking you for. You were given 5.67 liters of O2. Anytime you see liters, that means we'll be using the 22.4 at some point. So now that we know what is being asked of us, we can go ahead and start setting up our conversion factors. We always start with what we're given, which was 5.67 liters of O2. Remember to use your mole island, and whatever unit you have here needs to be the same unit that you have down here. So if we have liters here, liters needs to go here. We've already said that since we were given liters to begin with, we already know 22.4 is going to go in there somewhere. So if liters have to be at the bottom, 22.4 is our only thing we have with liters. So that's exactly where we're going to put it, is on the bottom. That's equal to 1 mole. So that will be on top because remember, we always want to convert to moles when in doubt. We set it up like that. Our liters of O2 will cancel. We're left with moles. Question is asking us for molecules. Moles and molecules are not the same thing. So we're not done. We need to keep going. Now, 1 mole of anything is equal to 6.02 representative particles. In this case, molecules is the representative particle. Whatever unit we have here needs to be the same one that we have here. That way they'll cancel. So if we have moles here, our 1 mole needs to go here, and our 6.02 will go on top. So we have our 1 mole of O2 at the bottom. Then our this looks horrible. Our 6.02 times 10 to the 23rd. That doesn't even look like a 2 or a 3. We'll do molecules. Will be on top. Once we have it set it up like that, moles of O2 will cancel. We're left with molecules. That's what the question is asking us for. So at this point, we can begin to solve this problem. So you will just multiply the things at the top and then divide it by the stuff on the bottom. Again, I'm going to tell you that you need to put this stuff in parentheses before you do it. So the stuff at the top, 5.67 times 1 times 6.02 times 10 to the 23rd, all that needs to be in parentheses. Then you hit your divided by, and then you can do your 22.4. If you don't put your stuff in parentheses, it will not come out correct because the calculator is not going to know to do order of operations for you. Once we get all of that in a calculator and you double check to make sure that you put things in parentheses where they go, it should come out to about 1.52 times 10 to the 23rd. And our units is molecules of O2. And that would be our final answer for this one. So again, guys, just to sum things up, please make sure that you read what the question is asking you for. Make sure you set up your proper conversion factors, determine what's given to you and what the question is asking you. And please make sure you use the T-chart. And if the mole island thing helps you, then please feel free to use that as well. Hopefully things are a little more clear now. See you tomorrow.